Number 1. In a right triangle, theta is an acute angle, and tangent of theta equals 8 over 15. Evaluate the other 5 trig functions for theta. So what we're going to do is we're just going to fill out this table here. Looks like I have a little bit of a typo. I'm going to just change that to 8 over 15. Okay, so the first thing we have to do is we have to figure out what our opposite, hypotenuse, and adjacent are so that we can answer these trig questions. So we're going to start with tangent. We know is opposite over adjacent. You should have SOHCAHTOA memorized. So tangent is opposite over adjacent. So I'm just going to draw a right triangle over here. I could put theta in either of my 2 acute angles. I'm going to put it down there. And I'm going to label my opposite side as 8 and my adjacent side as 15. So now what I have to do is find my hypotenuse. So we're going to use the Pythagorean Theorem. I've got 8 squared plus 15 squared equals c squared. So we get 64 plus 225 equals c squared. 289 equals c squared, and then we're going to square root both sides. We get c equals 17. So our hypotenuse is 17. Opposite, adjacent, and hypotenuse. Alright, so now we can fill this out. Sine is just opposite over hypotenuse, so 8 over 17. Cosine is adjacent over hypotenuse, so 15 over 17. And then cosecant, we just flip sine, so 17 over 8. Secant, we just flip cosine, 17 over 15. And cotangent, we flip tangent, 15 over 8. Number 2, know the 3 main trig functions and their reciprocals. So right up here in our table, it's kind of given to us. Sine is opposite over hypotenuse, and its reciprocal is cosecant. So hypotenuse over opposite. Cosine of theta is adjacent over hypotenuse. And its reciprocal is secant. And then last we have tangent of theta, which is opposite over adjacent, and cotangent, which is adjacent over opposite. For problems 3 through 5, we're going to solve the triangle for the missing side, x, or the angle theta. We're going to do that by setting up an equation using sine, cosine, or tangent, and rounding to 1 decimal place if needed. Alright, number 3, I'm solving for theta, because that's my unknown in the picture. I know I have my hypotenuse is 5, and my adjacent is 4. Since I have hypotenuse and adjacent, I'm going to use cosine. So we have cosine of theta equals my adjacent over my hypotenuse. The way that we solve for angles is we just need to get rid of cosine, and we're going to do that by doing cosine inverse on both sides. So I'm going to move cosine to the right by doing cosine inverse, cosine -1. And that gives me 36.9 degrees once I round to 1 decimal place. Alright, number 4 is going to be about the same, except this time we're looking for a side. We're actually looking for our hypotenuse. And again, we know our adjacent, so we will be using cosine. So we have cosine of our angle, which is 37, equals adjacent over hypotenuse. Okay, one misconception here is that you should multiply 11 over, and that will get x alone. Well, that doesn't work. We always want to multiply over whatever's on the denominator. So we're actually going to multiply over x. And then we're going to divide by cosine of 37 to get x alone. That gives me 13.8 as my final answer for this side. Number 5. Find the angle of elevation if you're standing 400 feet away and the building is 850 feet tall. I'm guessing you're standing 400 feet away from the building. So let's go ahead and draw a picture. I'm going to draw us right here. And we are 400 feet away from a building. So here's 400, and here's the building. And it says that my building is 850 feet tall, so I'm going to label that as 850. I want to find the angle of elevation. So the angle of elevation from me would be this angle right here. And here's our right angle. Okay, the two sides that I know are my opposite and my adjacent. So I'm going to be using tangent. We've got tangent of theta equals opposite over adjacent. Again, to solve for theta, I'm going to have to use an inverse function. So I'm going to do tangent inverse on both sides. And I get 64.8 degrees. Number 6. John wants to measure the height of the tree. He walks exactly 100 feet from the base of the tree and looks up. The angle from the ground to the top of the tree is 33 degrees. So here we go. We're going to draw a picture. He wants to measure how tall this tree is. So I'm going to draw a tree. And he walks 100 feet from the tree. So we're going to put John over here, and he's 100 feet away. When he looks up to the top of the tree, it makes an angle of 33 degrees. So that's going to go right here. And here's my right angle. We're trying to find how tall the tree is, so this is the side that we'll be solving for. We want to find our opposite. We know our adjacent, so we're going to use tangent. We have tangent of 33 equals our opposite over adjacent. Multiply over the 100 to get x alone. And we get 64.9 feet. Again, I just rounded to one decimal place. Make sure that you include your units of feet on here.